What is the super chimney and how does it work? The super chimney is a theoretical structure designed to achieve three main objectives. It generates electricity, creates water in desert environments, and cools our atmosphere. This presentation will explain the principles underlying the super chimney. The physical principle underlying the invention is very simple. Hot air rises above cold air because hot air is less dense and therefore it is lighter than cold air. In the atmosphere, masses of warmer air are constantly moving up and masses of cooler air are moving down. The process can be made more intense if we can prevent the mixing of warm and cool air. For example, the hot air contained inside a hot air balloon allows the balloon to rise. A chimney is very similar to a balloon in the sense that it prevents the air inside from mixing with the outside air until the air exits the chimney. The chimney's height is a very important factor when determining the speed of smoke or air passing through it. The taller the chimney is, the faster the smoke will rise. In fact, its speed increases exponentially. Let us take a moment to consider our atmosphere. As we climb up, the temperature drops 10 degrees Celsius every 1,000 meters. Why does this happen? Well, the answer is simple. Our atmosphere absorbs heat from the sun, and it absorbs more at the surface than high above. So we have a constant and readily accessible source of energy simply because of the temperature differential between high and low altitude. Let us assume for a moment that we can build a chimney that's 5 kilometers high. The air at the base of this super chimney will be roughly 50 degrees Celsius warmer than at its top. Such a difference in air temperatures, enhanced by the height of the chimney, will produce an incredible airflow. The air from the Earth's surface will be sucked inside and will travel at speeds of up to 300 miles per hour. While the pressure inside of the chimney will be comparable to the air outside, the temperature will be much warmer. The reason for this is the absence of adiabatic cooling inside the chimney. Consider the following. When a parcel of warm air rises from the surface, it floats up while expanding and pushing and compressing surrounding air on the sides. All of this causes the parcels of rising air to cool down while the surrounding air warms up. Now let's see what happens with the parcel of air inside the chimney. The parcel cannot expand on the sides because of the chimney walls, and the air pressure from below is higher than the pressure above. So the only way for a parcel of air to expand is upwards, thus pushing and compressing the layer above. As a result, the parcel cools down and the air above warms up. But the layer just below the parcel also pushes up and compresses the parcel, thus warming it up. This process repeats itself throughout the inside of the chimney. In other words, the temperature inside does not change. Only as the air rises and exits the chimney does it really cool. The air inside the chimney is substantially warmer and less dense than outside the chimney. Therefore, it constantly floats up the chimney and new air at the surface gets sucked in. The sun heats up our atmosphere unevenly, more at the surface than higher up in the atmosphere. This allows for stable airflow for the system. Now that we understand the principle behind the invention, let us see how we can utilize it. Since the super chimney maintains tremendous airflow, all we would need to do is attach air turbines in order to harvest this energy and transform it into electricity. Ideal locations for these chimneys would be in tropical areas or deserts because they are warm all year round, which guarantees temperature differential all of the time. Another good reason for choosing desert terrain as a viable location is the inherent ability of the super chimney to induce water precipitation in the surrounding atmosphere. When warm air is expelled from the super chimney, it is cooled down by mixing in with surrounding air. Once cooled, the air becomes oversaturated with water vapor, so water naturally precipitates in the surrounding area. High winds at high altitude will carry water over large areas with additional rain, which these areas normally wouldn't receive otherwise. Creating an array of chimneys will allow entire desert regions to be transformed into a tropical paradise. Adding water into a desert will change that desert from having carbon neutrality into a carbon sink, and significant amounts of CO2 will be fixed into newly formed soils. The super chimney will cool the Earth's atmosphere by facilitating a heat exchange. This is probably the most important aspect of the super chimney. We must understand that the phenomenon of global warming is caused not by the planet receiving more heat, but rather by heat being retained in the atmosphere due to greenhouse gases. Respectively, the super chimney will change the amount of heat released by the planet. It will accelerate the rate of the heat exchange in the atmosphere, which will in turn result in the reduction of Earth's atmospheric temperature. The super chimney will facilitate air convection by bringing masses of the warm air to high altitudes, resulting in warm air coming out of the super chimney's exit. When the heat from the air radiates out, it will already be at high altitude. Therefore, the amount of energy reabsorbed by the atmosphere will be less. This is due to a thinner layer of air for heat to travel through. As a result, more heat will be leaving the atmosphere, thus reducing the atmospheric temperature. The big question you may be asking yourself is, how would one go about building a super chimney? Many designs have been considered, such as construction within a mountain, on the side of a mountain, or simply a standalone structure. All of these designs have been rejected as they are too expensive and impractical. Finally, after much research, a solution has been found. The super chimney will be built of flexible materials similar to the fabric of a hot air balloon. It will be equipped with a mushroom cap to increase uplift by directing the reactive force of the exiting air in a downward direction, like a missile. Our calculations show that when a flexible and inflatable chimney is erected, the force of the blowing air when combined with the buoyancy of the system will be sufficient in holding the chimney in a stable, upright position. It will also be sturdy enough to withstand high wind speeds. Buoyancy alone will be sufficient enough to erect the chimney. At first, the chimney will have to be sewn from fabric. That fabric should be strong and heat resistant with low heat conductivity. Most likely, it will be a multi-layered material. The sewn chimney will be folded and fixed to the base of the lower end, and the mushroom cap will be fixed on the upper end. The openings of the mushroom cap will be closed. After that, we will start inflating the chimney by pumping hot air inside. We will also use hot air balloons to support the initial ascent of the mushroom cap. Then buoyancy combined with the reactive force will reach a sufficient level to maintain the ascent. Once the entire chimney is inflated, we will release the hot air balloon and open the mushroom cap openings. The airflow inside will quickly rise to the projected levels and the chimney will start functioning. Calculations show that building one 20-meter in diameter chimney can cost up to $5 million. 25,000 chimneys of this size are enough to stop global warming. The investment would cost less than $125 billion. Furthermore, as we get more experience with building super chimneys, we can make them more effective by constructing them to be taller and wider. As a result, the production cost of the chimneys will decrease. The benefits of the super chimney will result in millions of acres of arable land in former deserts around the world, as well as the production of fresh water and electricity. It is even quite possible that we can end up making a profit on solving our global warming crisis.